This is Ms. Black. This is Open Campus Math 102. We are still in Module 14. Now we're on 14G. We are still graphing parabolas. So far we've talked about the parts of a parabola, and we talked about how to look at the equation of parabola in standard form and get the vertex point, tell if it's going up or down, tell if we have a max or min, find the roots, find the y-intercept. So what do we have left to do? Well, what we have left to do today is what happens if I give you the equation of a parabola, but it's not in standard form. What I mean by that is it will not look like y equals a x minus h squared plus k. It will not have the parentheses in it. It will be in general form. And in general form, we're going to have to do some extra work. Because in general form, it's not going to show the vertex point. Now, we've done something similar to this already. If you think back to Module 13 on lines, think about an equation of a line, a diagonal line. You know a diagonal line has an x and a y, correct? And if you remember, if I give you the equation of a diagonal line, say 2x plus 5y equals 10. That diagonal line is not ready to graph. It is in standard form, and you had to change it to slope-intercept. Well, we're going to do the same concept today. I'm going to give you an equation of a parabola, a quadratic equation, that doesn't have the parentheses, which means it's not ready to graph. To get the vertex point, we're going to have to do some additional work. So let's look at our notes, please. Today, your equation of your parabola is going to look like it's looked in the beginning of the semester. It's going to look like y equals ax squared plus bx plus c. Again, if you look at that equation, you know it's not a line because the x is squared. It's not linear. You know it's not a circle, ellipse, or hyperbola because the y is not squared. So we've already discussed this. If your equation only has an x squared from the beginning of the semester, it's called quadratic. A quadratic equation only has an x squared in it. Its graph is called a parabola. There are two things you got to get out of that equation. The first thing you have to get out of is if it turns up or down. That will always be the a value. Well, if you look at this equation in general form, yes, it still has an a value. A is always going to be in front of x squared. So if you look closely, a is in front of x squared, and you will know if it turns up or down, just like we did previously. If a is positive, it will turn up. If a is negative, the parabola will turn down. What's different in general form is you do not see parentheses. So you do not see an h and k value. You do not have the vertex point by looking at this. So what's going to happen today that's different is because you can't look at the equation and get the vertex point h and k. To find the vertex point, you're going to use a formula. X equals negative b over 2a. It's just a formula. You're going to plug in the number for x. You're going to plug in the number, you're going to plug in the number for b. You're going to plug in the number for a to find out what x is. Where are those numbers from b and a coming from? They're coming from your equation. Because you all know if you have a quadratic equation, a is always in front of x squared, b is always in front of x. Everything else we do is the same, exactly like we did the day before. You're still going to have to find the y-intercept by letting x be 0. You're still going to have to find the roots, the x-intercepts, by letting y be 0. So, the biggest difference today is very simply, if your equation that's quadratic doesn't have parentheses, you are going to have to find the vertex point by using this new formula. All right, let's go up to the whiteboard and try one big example. Okay, ladies and gentlemen, here is the equation I want to graph today. So, if we put it all together, I'm giving you an equation. Every equation makes a picture. You should be able now to decide, is this going to be a line, circle, ellipse, hyperbola, parabola? You know it's not a line, it's not linear because it has an x squared. So the line is out. You know it's not a circle, ellipse, or hyperbola because both variables are not squared. A circle, ellipse, hyperbola have an x squared and a y squared. This equation only has an x squared. That guarantees it's quadratic. Quadratics make parabolas. Parabolas look like a U. They either go up or down. Every parabola, you could look at the equation and tell me whether it's going to go up or down by giving me its a value. A is always in front of x squared connected by multiplication. So if we look at this equation, I can see my a value. It is 1. If a is 1, this parabola is guaranteed to turn up. So in general form, a is in front of x squared connected by multiplication. If we were in standard form like the previous module, a is still in front of x squared connected by multiplication. So you can always look at your quadratic equation. That first coefficient is a. It tells you whether you're turning up or down. Now, the difference today is this. Because this equation is in general form and it does not have the parentheses, you do not know the vertex point. See, if it had the parentheses, then you would know your h and your k, and you could go plot your vertex point. So, what we're going to do is learn how do we take the parabola equation, the quadratic equation, and if it doesn't have the parentheses, how do we get the vertex point? Well, you're going to use this formula. X equals negative b over 2a. So you're going to have to memorize that. You know from previous lessons, a is in front of x squared, b is in front of x. So we can look up that equation and know our a and b value. We know negative b means the opposite of b. Remember when we were doing the quadratic formula? X equals negative b plus or minus square root. Remember that? Negative b means the opposite of b. So if your b is 4, this must be negative 4. Over 2 times whatever a is, 1. Negative 4 divided by 2 is negative 2. So what that you just found is the x value of your vertex point. But to be a point, you need an x value and a y value. To get the y value, you're just going to use simple algebra skills. If you know the number for x, you could substitute it in and get your number for y. And that's what we're going to do. We're going to write our equation. Y equals, instead of writing x, we're going to put negative 2 and square it, plus 4. Instead of writing x, we're putting negative 2 minus 5. Now, it's simple arithmetic. We're going to follow order of operations. Negative 2 squared is 4. 4 times negative 2 is negative 8 minus 5. 4 minus 8 is negative 4. Negative 4 minus 5 is negative 9. And there is your y value of your vertex point. So the only difference in today's lesson was right there. If the equation of the parabola is given with parentheses, you will know h and k, the vertex point. Today's equation, even though it's quadratic, it has the x squared, the parentheses are missing. So to get the vertex point, you use this formula, negative b over 2a, to get the x value. Then you take that number for x, substitute it into your equation to get your y value. Now, we know, without even graphing, whether this point is a max or min. If the parabola turns up, that point will be the lowest point, the min. And we know the value of the min because the y value of this point is negative 9. So when we go to graph this parabola, this u, the lowest point on the y-axis will be at the number negative 9. Now the problem is, With this equation, we got two pieces of information. We figured if it went up or down, we got a vertex point. That is not enough to graph a parabola. Because watch, if I go plot it, I only got to plot the vertex point. -2, -9. Plotting one point cannot make a parabola. I know it goes up, but you can't just draw the U. How wide do you make it? Do you make it really wide? Do you make it narrow? So now we got to go get the rest of our parts of our parabola. We're not done. Everything we do now, though, is exactly like we did the other module. The next thing you always going to find with a parabola is the y-intercept. Every parabola is going to touch the y-axis, regardless, whether it's in standard form, general form. Every parabola is going to touch the y-axis. To find the y-intercept, we use our rule that we've been using all semester. You let x be 0. So you take your equation, y equals, and you replace x with 0. So that would be 0 squared plus 4 times 0 minus 5. Simple arithmetic now. 0 squared is 0. 4 times 0 is 0 minus 5. So we get y equals -5. We've already discussed this with lines, so we're going to discuss it again. When you write a y-intercept, it is a point. A point's got to be written with two numbers. So the x value was 0. That's what you substituted in. You got out y is -5. So if you go plot that point, yeah, 0, -5 is on the y-axis. But that's not enough to graph a parabola, because that's only 2 points and that would make a line. So then we talk about it. If this parabola turns up, yeah, it's going to cross the x-axis. We got to find the x-intercepts. Another word for x-intercepts is roots. So I'm going to erase this work. To find the roots or x-intercepts, you learn the definition in lines. To find x-intercepts, you let y be 0. So you take your equation given, you replace y with 0. So that would be 0 equals x squared plus 4x minus 5. Well, guys, you're back to solving a quadratic equation. That's all the way back in Module 3. In algebra, you're always using skills you've learned previously. So now, how do you solve this? Well, we've discussed this. When you have a quadratic equation equal to 0, one of the easiest ways to do is to factor this. To factor this is to break it in multiplication. Because there are 3 terms here, a trinomial, we're going to put factor using the trinomial rule. We're going to put 2 parentheses. X squared is x times x. What multiplies to 5 and subtracts to 4 would be 5 and 1. I'm subtracting. The signs are different. Subtracting to +4, the sign goes in the middle to the bigger number. When you factor a quadratic, you make 2 linear equations. So we set each of these equal to 0 and solve for x. One solution is x is -5. One solution is x is 1. So you're going to have to go back and review Module 3 on solving quadratic equations to graph parabolas. The only way to find the roots, the x-intercepts, is to replace y with 0. When you take a quadratic equation and you replace y with 0, you are solving it, which means you have to either use factoring, the square root method, the quadratic formula. This was easier done by factoring. Now again, you will get marked wrong if you say that these are the roots without writing them as ordered pairs, points. The first root is at -5, 0. X is -5, y was 0. The second root is at 1, 0. So let's plot those. 1, 0, -5, 0. Well, that looks good. We have 1, 2, 3, 4 points. It's looking like a parabola. But I said to graph a parabola, you either plot 3 points to make a pretty U or 5 points. Somebody's missing a buddy. And that's why the next part, the axis symmetry, is so important. I would draw the axis symmetry in my picture. The axis of symmetry is always a vertical line that cuts the parabola in half, and it goes through the vertex point. So if you draw that axis of symmetry in, everybody look. These 2 points are buddies because they're the same distance away. 1, 2, 3. 1, 2, 3. Every point's got a buddy except for this vertex point. So this point's got to have a buddy. Well, this point is 1, 2 away from the axis of symmetry. So his buddy is going to be 1, 2 away. Now I have 5 points. Now I can make my pretty parabola and graph it. And it's supposed to be a letter U, so make it look like a curve. It's got to go through all those points. It's got to have arrows. So what you got to understand is to graph a parabola, you will not get all the information by just looking at the equation. You will always get whether it turns up or down by looking at the equation. If x squared is positive, the parabola turns up. If x squared is negative, the parabola turns down. That's a given. Sometimes you will get the vertex point if it's in standard form, where you can see the h and the k. If the parabola is not in standard form, but in general form, then you're going to have to use a new formula to get the vertex point. You are always going to have to do work to get the x and y intercepts. You are always going to have to set x equal to 0 to find the y-intercept, and set y equal to 0 to find the x-intercepts. And once you have all that information, then you could graph the parabola. Now, we have 3 questions to answer. These questions don't require any work now. So, our last 3 questions are to name the axis of symmetry. Write the equation of the axis of symmetry. If you draw the axis of symmetry in, you will notice it's a vertical line. From Module 13, vertical lines are named x equals. What is the value of this vertical line? Well, if you look, it touches the x-axis at -2. This number in the equation of the axis of symmetry is always the x value of the vertex point because it goes through the vertex point. Then they will always ask the parabola's domain and range. And we said those words do not mean the same thing as intercepts. When I ask you the domain, I'm asking you how far to the left and how far to the right does the parabola travel, because it's following the x-axis. Well, this parabola has arrows on it, and as it goes up, it opens out. So it is going to travel all the way to the left as far as you want it. So we would say the domain would go from -infinity, and it will travel as it goes up all the way out to the right to +infinity. And that is in interval notation, something we learned modules ago. And infinity always goes in parentheses. You can memorize that fact. The domain of a parabola, whether it goes up or down, is always going to travel all the way to the left, all the way to the right. Because as it goes up, it widens. As it goes down, it widens. The range is a different story. Range means low to high. How low does it go? How high does it go? Range means traveling the y-axis. Well, if you look, here's the y-axis. This parabola is only going to go as low as here. There is no parabola down here. There is no curve down here. So this is as low as the parabola goes. That's why that's the minimum. And its lowest value is at -9. So we would say for the range, the lowest value is -9. But the highest value, points get higher, points get higher, points get higher. Because it's pointing up, it's going to go as high as it wants. It's going to cover all these y values. So because it's pointing up, we would say it goes to infinity. Infinity always gets a parentheses. But because this is an actual number, -9, where there's a point located, it gets a bracket. What you're telling me is if I look at my picture of my parabola, it is on the y-axis from -y, -9, all the way up. And that's everything we have to do for a parabola. So now we have finished graphing all four curves: circle, ellipse, hyperbola, parabola. We have one more module to talk about. I'll see you then.